Good afternoon, everyone. Thank you for coming to the last seminar of the term. It's been a great series looking at the blurring lines between humans and technology. This afternoon will be no exception. We've got a great seminar lined up. If you want to tweet, the hashtag is HumanTech. Obviously, please make sure all devices are on silent. And welcome to those of you watching online as well. I'm very pleased to announce our speakers this afternoon. Some of you, I'm sure, will be aware of the extensive coverage that their most recent paper got, and indeed that's probably why some of you are here today. It's The Future of Employment, How Susceptible Are Jobs to Computerisation. So that's going to be the basis of the talk today. We have Dr. Carl Frey, who's an economics associate at Nuffield College, and he's James Martin Fellow at our programme on the impacts of future technology. His research interests include the transition of industrial nations to knowledge-driven economies, subsequent challenges in terms of economic growth, urbanisation, labour market polarisation, and the financing of innovation. Much of his work focuses on technological change and its potential impacts on labour markets, as well as on income inequality. Before he joined academia, Dr. Frey also worked as an economist in both government and the finance sectors. Dr. Michael Osborne is Associate Professor in Machine Learning here at Oxford and co-lead of the Machine Learning Research Group, which is part of the robotics team within engineering. He's also an affiliate of the Oxford Man Institute here. His research interests focus on the design of intelligent systems with algorithms capable of substituting for human time and attention. He has worked to apply his novel techniques to scientific and engineering problems in fields as diverse as astrostatistics, ornithology, and sensor networks. His DPhil work was on sensor networks and had a significant influence on the EPSRC industry research project Aladdin, which was winner of the Engineer Award Aerospace and Defence in 2009. So I hope you'll all join me in welcoming both our speakers.
Well, thank you, Carol, and many thanks to the Oxford Martin School, indeed, for organizing this important seminar series on the changing dynamics between man and machine. In this final lecture, Mike and I will focus on how these dynamics are likely to impact on labor markets in particular. And we will also try to highlight how this compares to the past, because needless to say, technology destroying jobs is nothing new. And it has arguably been at the center of economic debate for centuries. And as many of you will have heard, in 1930, 84 years ago now, John Maynard Keynes made broadly actually an optimistic prediction in saying that, well, while we're going to see some technological unemployment in the future, this is essentially going to be a temporary phase. And in the end, long-run technological progress will actually solve mankind's economic problem and deprive us of our traditional purpose of subsistence. Following, I think, a couple of decades now of actually surging income inequality, contemporary commentators tend to be somewhat less optimistic. And I think, well, the optimism is shown, somewhat captured by the recent cover of The Economist, with the tornado sweeping through the workplace, making our skills redundant at a faster pace than perhaps ever before. Anyhow, so what we want to achieve by this presentation is simply a thought-provoking discussion, because there's nothing inevitable anyhow to anything of this. We can continue down the path of growing income inequality, or we may perhaps end up somewhere closer to what Keynes once suggested. It's really up to us to shape how these things turn out. That being said, the agenda for today's talk is that I'm going to first start out making a somewhat sweeping introduction to the history of technology and work. Mike will then provide a more forward-looking perspective, saying what is actually happening, what the main technological developments these days are, and highlight some of the findings of our studies where we examine the employment impacts of these type of developments. And then I'm going to make a short comeback and try to sort of throw some ideas in there in the hope that the later discussion will flourish. So now, technology can shift fortunes of people and places. And this was something that was observed early on by Schumpeter, who basically suggested that technology is a disruptive force that sustains economic growth, but it does so by making the value of our capabilities and skills obsolete. And in Schumpeter's view, it was actually not so much the lack of inventive ideas that set the boundaries for economic development, but rather social and economic interest that tried to maintain the technological status quo. So what this essentially means is that the balance between job conservation and technological progress to a large extent reflects the balance of power within a society and how economic returns from progress are being distributed. And I think that this is nicely reflected by the neat historical example of William Lee, who in 1598 invented a stocking frame knitting machine, hoping that it would relieve workers of hand knitting. And mildly proud of his invention, of course, he went to London, where he had rented a room for the machine to be viewed by Queen Elizabeth I. And to his disappointment, she wasn't too keen on it, and she actually refused to grant him a patent, and actually claimed that, though aim is high, Master Lee, consider though what the invention could do to my poor subjects, it would assuredly bring them to ruin by depriving them of employment, thus making them beggars. And the opposition, or this stand taken by Queen Elizabeth, was most likely a manifestation of the guild's concern over this invention making the skills of the artisan members obsolete. And their opposition to the invention was actually even so intense that William Lee eventually had to leave Britain. But after the Glorious Revolution of 1688, where William and Mary arrived in Britain, the balance between Parliament and the Crown somewhat shifted. And the result of that was in many ways that merchant and factory owners, which were typically less hostile to technological progress, gained in political influence. And although we're still clearly opposition to technological progress, workers didn't have the influence or the political means to actually prevent these technologies from their diffusion and implementation. And in fact, when the Ludwig riots happened in 1811, when workers went out and smashed up machinery, the army even deployed 12,000 men against the rioters. And I think this tells you something about the shift in attitudes towards technology, which we've seen before and after the industrialization. And what happened with this shift in attitudes was that the process of creative destruction was allowed to take place much more rapidly. And what followed was essentially an economic transformation of unprecedented magnitude, as the artisan shop, where basically the worker conducted all tasks in the entire production process, was replaced by the factory system, where work was being decomposed into highly specialized sequences requiring less skill but more workers to perform. And you can see here, for example, in the production of plows, which actually happens. In the artisan shop, 2 people were working. In the factory, 52. Total hours per output in the artisan shop, 118 hours. In the factory, 3.75. And the number of tasks increased from 11 to 97. And it was exactly this type of transformation that eventually enabled corporations such as the Ford Motor Company to manufacture the T-Ford at a sufficiently low price for it to become the people's vehicle. Then something happened. And I do believe that the picture sometimes tells you more than 1,000 words. So what happened to the worker in this picture? Well, an important feature of the Industrial Revolution and the factory system was actually that the division in labor more or less routinized production. And as the first industrial robots and computers came along, it didn't take a long time before the entire factory system was more or less automated. And to give you an idea of how fast this can actually happen, consider the first automatic car wash. It was developed in Seattle in 1951. And if you can see here, as you can see here, you can see on the axis the car washers and greasers employed in the US over time. And you can see what follows 1951 when the first automatic car wash actually arrives. And there's clearly some innovative solutions to the car wash along the way, but it wasn't until then that we saw this magnitude and employment essentially falling down to zero within only a couple of decades. So, despite all of this, and despite a huge surge in computer power and falling cost of computation, we still haven't seen too much resembling what we would call technological unemployment. And the reason for that is basically that while computers are very good at performing routine work, which is easy to specify in computer code, they are not very good at performing a lot of other tasks. And this is something Mike is going to talk to you about in a bit more detail later. But what you can see on this graph is that the increase in service employment actually more or less mirrors the decline in manufacturing employment. So the story of the past couple of decades is clearly not one of technological unemployment. The story is, however, one of growing income inequality. Because what has happened in most countries is that while computers substitute for much routine manufacturing work, it at the same time complements most cognitive work. The work of most engineers, the work of most managers, the work of most financial analysts have not been automated, but nevertheless computers have been a great help to most of those occupations. And the result has been increased job growth in most high-income occupations. So what about the low-income occupations? Because there have been quite a bit of job growth there too. So what happens is that, roughly speaking, when you create one high-income job, the person in case goes out in the local economy and spends the money on services. And that is essentially the process that explains this hollowing out of the middle with job growth occurring on the low income, or the bottom of the income spectrum, and the very top. And so what we can learn from economic history, I think, is that, well, first of all, there's no really monotonic relationship between technology and employment. During the Industrial Revolution, technology replaced skill, created more low-skill jobs, while the trend over the past couple of decades has actually been this hollowing out, where we see in technology substituting for middle-income jobs, but creating an ever-increasing demand for skill. So on the basis of economic history, it's clearly difficult to predict what actually will happen. And the approach we decided to take is therefore rather look at what's happening in technology and see how the type of tasks that computers are able to perform are likely to expand looking forward. And that is something that Mike is now going to talk to you a bit about.
Thanks, Carl. Can everybody hear me okay? So, just kind of pick up on a couple of those points. So you've heard I work in machine learning, and I wasn't sure how many in the audience would have heard of machine learning before and kind of what it means. So I thought I'd put up this slide to start to sort of set the scene. So hopefully everyone's heard of artificial intelligence. And machine learning is really just a subfield of that, involving a host of different technologies related to reinforcement learning, learning theory, machine translation, and a lot of things kind of interrelated with it, like computer vision, the ability of computers to process images, robotics. So I think what sets machine learning aside from previous disciplines dedicated to developing technologies are two things. So the first of those is that we really do know that what we're trying to do is possible. There is a proof of concept for technologies that can perform human-like tasks, and that is humans. So we know ultimately our goal is achievable, and secondly, and more importantly, we know there's a huge demonstrable market for the kind of things we're trying to develop. And exactly as Carl has alluded to, that is human employment. We're trying to actually design algorithms that can do what human workers do, cognitive tasks that have previously been the domain of human workers. So the question you might ask is, why would we want to do that? Why would we want to replace humans with machines? So to illustrate that, I've got a graph from perhaps one of my favourite papers of all time. So if you study that, the x-axis is time, ordinal position through the day. So let's see if this laser pointer works. This point here is the mid-morning break, where you have your morning Snickers bar. This is lunch. The y-axis is the fraction of favourable decisions, the fraction of decisions to award parole to prisoners made by Israeli judges. So as you can see pretty clearly, Israeli judges get more and more grumpy as they get hungrier and hungrier throughout the course of the morning. Then that Snickers bar picks them up, they get much more happy, until of course the grumbling of their tummies for lunch impedes their ability to make reasonable, unbiased decision making. And it's exactly that we might want to investigate machines to do, right? We want machines that are able to get rid of some of the heuristics and biases that humans have. They're able to perform clear-headed decision making. So that's one reason you might want to have a machine rather than a human. This, of course, is the other. It's simply that machines are getting cheaper and cheaper. So I'm sure everyone has seen a plot somewhat like this in the past, but the x-axis is time, the y-axis is the cost of a single unit of computing, and you can see this very clear downward trend. So a computer is getting cheaper and cheaper over time, with a possible exception of the iPad 2, which you can see is a bit of an outlier there. So, kind of associated with that trend, cheaper and cheaper computing, is this phrase that, again, I'm sure everyone in the room has heard of, big data. And really all that means, if it means anything at all, is just that there's more and more data available. And to give some idea of exactly the scale of that phenomenon, I've got these following amazing facts. So there was an estimate made of the total information contained in all printed material in the world today, and that estimate was about 200 petabytes. Someone else did an estimate for the information contained in all the words ever spoken by hominids throughout the course of human history, and that was only about 5 exabytes. Both of those are completely dwarfed by the estimated internet traffic next year, which is approaching 1 zettabyte. So we really are seeing data at a scale completely unlike what we've seen before, and it's not surprising that this might have some sort of significant consequences. So in particular, we're already seeing big data leading to the automation of jobs that previously people thought were completely beyond the realm of automation. So one of the most prominent examples of that is in translation, machine translation, the ability of machines to translate text from one language to another. So it might not be clear if you haven't delved into these issues too much exactly how big data is influencing these kind of occupations. So to illustrate that, consider the United Nations, which is required by its charter to translate every document presented to it into the I'm talking about the EU here, not the United Nations, I apologise, to translate text into 6 different languages. So if we're trying to translate a particular phrase found in one of those particular documents, we can simply find the other documents that have already been translated by humans, pull out the appropriate phrase, and we've got our translation performed for us. So more and more machine translation is working along these sort of lines. It's exploiting the enormous corpus of pre-translated text that people have assembled to identify patterns and basically do the task of a translator for us. We're already seeing the impact of big data on tasks such as paralegals, contract lawyers, patent lawyers. So here is a quote from an article in the New York Times a few years ago, where this prominent lawyer said that he was no longer able to bill out the time of his sort of entry-level patent lawyers and paralegals, essentially because algorithms are now better able to dig through data than humans. So if your job basically relies upon you being able to sift through large amounts of information and pull out the right bits of it, I'd be quite worried, because that is something that algorithms are increasingly capable of doing. So of course we're seeing increased automation in retail and sales. Probably everyone in the room has used an automatic checkout at some point. Online sales is absolutely booming, again due to the impact of big data that's able to make recommendations to customers based on the spending patterns of customers in the data set. And I'd like to highlight the particular example of autonomous vehicles. So again, this was a task that was thought for a long time to be completely beyond the realm of what machines and algorithms could do. So as recently as 2004, these prominent economists, Levi and Manane, made the claim that executing a left turn against oncoming traffic involves so many factors that it was hard to imagine ever discovering the set of rules that could replicate a driver's behaviour. So a pretty strong claim. But needless to say, less than a decade later, 8 years later, Nevada issued a driving licence to the Google car. And of course, autonomous vehicles are now just going from strength to strength. So clearly, big data is doing something unprecedented here. And to make it clearer what big data is doing for this autonomous vehicle example, really what it's doing is to solve the navigation problem. That is, one of the key challenges in designing an autonomous vehicle is working out where you are in the world and how you should respond to it. So I'd like to try and illustrate this point with an example from my own life. So I moved to the UK in 2006 from sunny Australia, never having seen snow before in my life, right? So when it first snowed, I was completely bewildered as to whether or not I could cycle outside. It wasn't a problem that had occurred to me before. I wasn't sure if the tyres would grip onto the surface sufficiently that I could stay upright. I wasn't sure if it'd be safe, if my boots would get completely covered in mud. Despite the fact that I had an undergraduate degree in physics, I wasn't able to reason from first principles about whether or not this would be possible. So that second process there was basically what roboticists were previously trying to do in designing autonomous vehicles. They were trying to reason from first principles about what they could detect in the environment around a car, where it was in the world and how it should respond. But that's more or less the wrong way, right? So now I've been in the UK for 8 years or so. I've seen snow a couple of times. I've built up this depth of experience. I've seen other people cycle in the snow. I have all this information pertinent to how to operate under those sort of circumstances. And that's the new paradigm that's really taken over in this example of autonomous vehicles. Now people are kind of putting aside the attempts to solve these problems from first principles and are just gathering sufficient data that they can refer to the data in order to work out what to do in any particular circumstance. So as an example of where these autonomous vehicles are already making an impact on employment, let me highlight the QC bot. So these are kind of being deployed in hospitals around the world. So they're these cuddly little creatures that basically deliver medicines, materials and meals where they're needed in the hospital. But we expect that a lot of these kinds of logistics tasks are going to be automated in the next 10 to 20 years. So to give some further examples of where we think this is going to have impact, occupations like taxi drivers, forklift drivers, truck drivers, cargo handlers, we think are all going to be highly susceptible to this kind of computerization. So the question that's probably occurring to you is, if you're like any of the readers of our work, so if machines can drive as well as me, if they can serve customers online, if they can look data as well as, or maybe even better than humans, what am I still good for? Very reasonable question to think. So another focus of our work was to try and identify the bottlenecks to automation. What are the things that humans are still much better at than machines? So the first two I think will probably resonate with everybody. So if your occupation involves a great deal of creativity or social intelligence, the ability to interact with people, to negotiate or persuade, we think your job is relatively safe. These are skills that machines are not imminently going to be able to replace humans in. So the third bottleneck we identified is maybe a little bit more surprising, so I'd like to spend a bit more time on that. So autonomous manipulation is also still quite difficult for a machine, and that's basically due to the difficulties in perception. So if I were to reach over and lift up this glass, that's something I can do without thinking about it too much, maybe a little bit more in this case because I'm a bit nervous and my hands are a little bit wobbly. But in general, I've got a whole host of information that that tells me how to interact with that particular object. All that information we need to supply manually to a machine that's going to have to perform a similar task. So in order to interact with that glass, I first of all need to distinguish it from the background, which is a little bit tricky because in this particular case it's transparent, I can see through it. If I want to lift up the glass, I need to have some understanding of how hard to grip it, how much force I can apply to the glass without shattering it, and how much force is required to lift it off the table. So for that reason, that sort of deep understanding of our environment is still far beyond the ability of many machines. So for that reason, there are a whole host of tasks that are still going to remain human only for the foreseeable future. That being said, wherever you can kind of implement a workaround, we may see some intrusion of robotics into tasks requiring manipulation. So I've got some examples here of what the sort of state of the art is in robotic manipulation. This is a standard sort of robotic gripper. This middle picture illustrates quite an interesting little bit of innovation from a couple of years ago. So basically this is a hacky sack, or a balloon filled with rice, hooked up to a vacuum. So it picks things up by basically pushing down on an object and then sucking the air out. So it basically sidesteps all this difficulty of perception. It just grips an object by this kind of vacuum hacky sack thing. And I think we will see quite a bit of that. Wherever we can kind of design a workaround, we may be able to automate some occupations. They're not going to be able to replace the full generality of human manipulation. So to kind of drill into some of the things I was identifying there, what distinguishes tasks that are susceptible to automation from tasks that aren't susceptible to automation when it comes to these kinds of perceptive or manipulation tasks is really the degree to which the task can be structured. To what extent can this thing we're trying to do be defined as a crisp problem? So by that, we really need to distinguish, for example, factories from your home. So if we're in a factory, and here we have an example of Kiva robots, so robotics, a robotics company that was purchased by Amazon for almost $800 million US, I think, last year. So basically they've solved the problem of moving objects around a warehouse by, first of all, a warehouse is a very structured environment to begin with, right? The floors are flat, the lighting conditions are even, there's a very limited number of objects in that sort of environment. And Kiva Robotics have kind of taken an additional step even beyond the structure that's already inherent in a warehouse. They've placed these little barcodes, you can maybe just see those in the picture there, on the floor throughout the warehouse so that they basically tell the robots, which are these little orange devices, exactly where they are at any point in space. So they've completely abstracted away that navigation problem. Such a thing is not going to be possible in much more unstructured, cluttered, complex environments, like, for example, the family home. So if your home is anything like mine, probably you've got a whole host of different objects scattered across the floor. You've got pots and pans in various unlikely places. And it's very difficult for a robot to deal with that. So the kind of optimistic forecast we've been hearing of for maybe 50 years that any day now we'll have a robotic housemaid are just unrealistic. It's very difficult for a robot to distinguish between the dirt in a pot, for example, that's to be cleaned, from the dirt in a pot that hosts a pot plant, for example. You know, that's very intuitive to us. It's something very difficult for a robot to understand. It needs to have all this deep understanding of how hard to move objects, how hard to grip objects in order to move them. A home is a very difficult, unstructured environment. It's not going to be susceptible to automation. But other places where there's already a great degree of structure, like, so I highlighted warehouses, places like airports, hospitals, like the QC bot we saw before, all are probably going to see increasing amounts of automation just because the challenges there are smaller. Okay, so this slide kind of captures some of what I've been talking about. These are our 3 bottlenecks to automation, and this is sort of a cartoon for how we expect those different bottlenecks to influence how susceptible any particular occupation is to automation. So we think social intelligence and creativity are very important in determining whether or not your job is at risk. So, if you're a fashion designer or public relations officer, maybe that's debatable. I've had a few people question that. Probably your job is beyond the scope of automation for the time being because it just involves too much creativity and social intelligence, respectively. Perception and manipulation, another bottleneck, but perhaps it's less clear, right, to what extent that makes your job safe from automation. So this was a cartoon. Our analysis tried to make some of this intuition more concrete. So to do that, we dug into US Bureau of Labor Statistics data for 702 different occupation classes in the US. And for each of those occupation classes, we had a host of different self-identified characteristics. So basically, agencies in the US had gone out and interviewed people in each of these different occupation classes, which might be, for example, things like, exactly as the slide says, boilermakers or fashion designers, and asked them to what extent their job involved finger dexterity or the ability to negotiate with other people. So for each of those 700 occupations, we've got this vector of features telling us exactly what that job involves. So we thought that we could use that data to try and predict whether or not a job would be automated. The problem for us was, as Carl alluded to before, we don't have a training set. And by that I mean, we don't know for sure which jobs are going to be automated and which aren't. So we could have looked at historical trends. We could have said, what jobs have been automated over the last 20 years or so? But really what I've tried to highlight is that we are seeing some kind of step change here in technological development. So previous technological development was much more focused on substituting workers in manual tasks, routine manual tasks, whereas the kinds of technologies we're now seeing developed are increasingly going to substitute for workers in cognitive tasks, completely unlike the previous kinds of technology. So instead what we did was to host a workshop in Oxford. We got together a whole bunch of different experts and asked them what occupations they thought were definitely going to be automated and which weren't. Basically, we hand-labelled 70 of the 700 occupations as being definitely automatable or not. So this is not that data. This is just kind of a cartoon to illustrate the problem we're trying to solve here, which is the classic machine learning problem of classification. So basically, we have this feature vector corresponding to what each of these jobs involves. So X1 might be the extent to which any particular job involves persuasion. X2 might be the extent to which any particular job involves finger dexterity. And we'd label the job with a purple dot if we think it's definitely not automatable, a red dot if it's definitely automatable, and then we use an algorithm, a machine learning algorithm, to try and predict the probability of any other position in this space being automatable. So basically, we provide the algorithm with these purple and red dots. The algorithm gives us this landscape of probability, and then we can ask the question, okay, given a new job, one of the other 690, which maybe sits at this position, what's the probability of it being automated? So that's the analysis we did. So the outcomes of that analysis were to just highlight some particular things. The jobs that were most at risk were occupations like telemarketers, tax preparers, insurance appraisers. Hopefully, to you that sounds somewhat intuitive. These are the kinds of occupations we expect big data might be able to substitute for. Likewise, the jobs least at risk were things like occupational therapists, mental health counsellors, primary school teachers, all jobs that require a lot of social intelligence. Here are these plots of the probability of computerisation as a function of those different features. So you can see we do have these very strong negative trends in features like, for example, social perceptiveness and originality. So the more original you are, the higher this score is, the less probable your occupation is of being automated. Likewise for social perceptiveness. We got weaker trends in some of these other characteristics, things like finger dexterity and manual dexterity. And that's due to, kind of some complexities in our data. So a typist, for example, might rank their job as requiring a lot of finger dexterity. So we think typists are actually very susceptible to automation. Their job characteristics, as self-identified, suggest they're not. That's some of the kind of uncertainty our algorithm has to deal with, but nonetheless it does this fairly reasonable job. And then to perhaps the headline plot of our entire work. So this is kind of a lasagna representing the entirety of US employment according to the probability of computerization. So the layers of that lasagna correspond to different occupation classes. So the different colors correspond to, for example, blue represents management, business, and financial occupations. Yellow represents production. And we've kind of smeared that lasagna out according to that probability of computerization. So we can see here, unsurprisingly, management occupations, science occupations, education occupations that require a lot of social intelligence are relatively unaffected by automation. Jobs that are susceptible to automation, we're seeing production jobs, logistics jobs associated with transportation as being very susceptible. None of that's very surprising. Office and administrative jobs, where we think big data is going to increasingly substitute for workers whose job basically involves processing information, again, very susceptible. Alarmingly, we see these big chunks of at-risk jobs in sales and service occupations. So to some extent, that's not surprising. I mean, in the last downturn in the US economy in 2008, I think 1 in 12 sales jobs were lost, exactly due to this kind of replacement by online sales. But nonetheless, this has been one of the big areas of job growth in the US over the last decade or so. So if these jobs come under risk, we really are going to see a lot of change. And the final thing I wanted to mention, so we could also assess the probability of a job's computerization by 2 other characteristics that we can get from our data. Firstly, the degree to which any particular person in that occupation has a bachelor's degree, and secondly, the average amount you earn in any particular occupation. And in both of those characteristics, we see these very strong negative trends. So basically, the more you earn, the safer your job is, the better educated you are, the safer your job is. So perhaps not surprising, but obviously a bit alarming. And on that point, I'll hand back over to Carl. Thank you.
So, despite the potentially huge magnitude automation may have on the labour market in the future, some people may still say, well, is this actually all that different? And one sort of rather a bit thought-provocative picture from a recent issue of The Economist shows this graph where you see that in the beginning of the first couple of decades of the Industrial Revolution, wages were actually more or less stagnant, more or less looks the same as it has done over the past 30 or 40 years. I left off saying that I think economic history is a bad predictor of these things. And I'm not going to go out and make any predictions on the basis of this. But I do think that there are things we can learn, because arguably the computer revolution, the trends we've been seeing with computers substituting for routine manufacturing work and complementing cognitive tasks, has been with us for a couple of decades, and places have adopted very differently to these technologies. And the main example of completely failing to adapt is obviously Detroit, which filed for Chapter 9 bankruptcy last year. And it is important to remember that Detroit was actually one of the richest places on the planet back in 1950s. But it has since then lost in population every single decade. And it's become more synonym with urban poverty than anything else. But this was not destiny. Detroit was a city that invested in structures rather than people. And I think that there are certain takeaways from that. A place that was in similar trouble, and actually back in 1975, New York almost filed for bankruptcy, have actually adopted, some might say, tremendously well. I mean, after all, New York is one of the most wealthiest, perhaps arguably some of the most prosperous places in the world. But it's also so at a price, and that price is surging income inequality. And this is not just because of New York's huge financial sector. If you look at places like San Francisco, you will find a similar picture. So is the choice then actually stagnation or inequality, or is this simply a false dichotomy? Maybe it's actually essential that along the development path, more people actually get included in the economic growth we see. And arguably, some of the Scandinavian countries have managed this reasonably well. I mean, most Scandinavian countries, inequality is also growing, but it's clearly not at the same level of New York. And I would dare to make the claim that more or less the same technology that are being used in New York are also implemented in Scandinavia. So I don't want to make any particular recommendations looking forward, and I'd like to leave this open for discussion, but I would like to highlight one final thing, because I think when we speak about all these risks, it's also sometimes easy to forget all the tasks technology have relieved us from, which we actually don't want to do. And the work of laundresses was clearly not as charming as Renoir envisioned it. And you can see what happened there in 1910 when A.J. Fisher came up with the first electric-powered washing machine. Employment simply fell and fell and fell. And there are very few laundresses in the labor force today, I can tell you that much. But it also allowed, especially women, to not do so much work in the home, but actually go out in the labor force and do much more self-fulfilling work. So I think we do want to also, when we discuss these things, keep Thor in mind, the automatic washing machine. And I would simply say that we don't want to go back to the days before the Industrial Revolution, when technological progress was held back. And I think that's all for us today.
We have plenty of time for questions. What I'd like to do is get a feel for where in the room they are, so I don't send Clara running around too much. Can you put your hands up if you do have an immediate question, and we'll take the first round. None? Oh, God. Phew. There's one towards the back there, and then these two gentlemen in the front row.
Hello. My name is Freeland Wild from the Open University. I'm member of the scientific board of an €8 million funded research project in which we bring technology-enhanced learning to manufacturing environments using technologies such as Vuzix, Laster, Meta, Glass as a job performance aid to help people on the job learn better and quicker. And from that perspective of manufacturing environments, I'm not sure I share the bleak picture you paint here. If we look at the skills gap as evidenced in, say, the joint employment report of the European Commission or by consultants up and down the road, what we're actually facing in Europe, in North America, and in other markets around the globe is a shortage in high-skilled jobs. This erosion that you talk about, this is an erosion of low and middle-skilled jobs. In fact, the automation and investments into advanced machinery have rather increased the demand in workforce, but only for the high-skilled jobs. And I think from that perspective, the correct answer to tackle this problem is an investment in education, an investment in training, and an investment in learning technologies.
I don't disagree with that at all. In fact, I think it's essential. And what I would say to all the pessimists in general is that we haven't really tried to fill this skills gap yet. Because right now our educational system is very much focused around storing and processing information, which I guess is essential for us to learn in the first instance to perform a wide range of other tasks. But we can't simply leave it at that. We need to make sure that workers are actually fit to work with computers. And there's no reason why you shouldn't learn computer programming or statistical modeling reasonably early in school. There's no reason why that shouldn't happen at all. And there's also no reason why we shouldn't employ more of the technologies that actually help automate a lot of back office work, because teachers are swamped in simple back office work. A lot of that could probably be automated. And there's also no reason why we shouldn't apply more online education technologies, because what we want teachers to do is actually to work with students in interactive ways. Social skills, creativity, those are the domains where we still have the comparative advantage, and teachers should focus on helping us acquire those skills rather than anything else.
If I could just follow that up, I mean, your intuition that it's the low-skilled jobs that are at risk is exactly what our analysis found. I mean, there was almost this monotonic decreasing trend in the probability of computerisation with skill level.
Hi. The story about Queen Elizabeth I and the stockings, my first reaction was, well, aren't there going to be cheap stockings coming from France? And then I realized that this is 1600. But today, it seems that the only way any country, it's impossible for a single country to slow down any automation because it's a global marketplace. Does that seem right? That it just has to be accepted, and then one has to deal with how to deal with it, like education or something. There's just no way to slow it down because of the global marketplace.
I think some places are trying, and they look like North Korea. So yes, I will very much agree with you. I think yes, not too much else we can do.
Oh, yes. I was just intrigued because those two people said something about cars turning left, which in the UK would be turning right. And comparing that to the situation of the home, because you've got robots around factories, which are organised, whereas homes are disorganised. But then turning right into a road is quite a disorganised process. So are you perhaps being a bit pessimistic about our ability to automate, the processes of tidying up a house?
Well, okay, so I think actually driving is a much more structured task than our intuition tells us. I mean, we've done a lot of engineering of roads, so they're very easy to interpret, right? We put lines down the middle, we put up stop signs and traffic lights. The other objects we have to interact with are a regular sort of size, traveling at a regular sort of speed. I mean, there's a lot of structure in that environment of driving that we're able to exploit when designing a robot to navigate that environment. I still think that's not true of the average human home, at least my home. I mean, there's just a much greater variety of objects you have to interact with. They change from day to day, they move around. I mean, I think the pessimism about the susceptibility of home cleaning to automation is actually pretty spot on. Sorry.
Not like in 10 years.
Yeah, well, I'd be very happy to be wrong, I can tell you. Yeah.
Hello. I have two questions, one on the tech, one on the economics. Your chart that shows computer prices falling, it seems to be approaching zero. For how long can you therefore say that the growth in computer processing power, or whatever underlies that graph, will be exponential? And then on the economics, the relationship you show is technological change leading to inequality. To what extent can you say there's a feedback loop there? Because let me think, if I'm in your world and I'm getting much richer because I've got lots of robots, then I would like lots of people to be socially intelligent around me, to fold my washing perhaps, to counsel me, to be my yoga instructor. And I was just wondering to what extent you've looked at the extent to which inequality may therefore impede further technological innovation if people are working as washers rather than algorithm people, or whatever they're called.
If I could address the first, so you've asked sort of the $24 million question, will Moore's law continue? I can only speculate, of course, but I mean, the first point to make is that probably we're going to see computerization over the next 5 to 10 years just due to the current level of computing, right? Like, we don't need computing to get any cheaper in order to automate a lot of jobs that currently exist. So even beyond we speculate about whether or not that trend will continue, we know there are going to be significant effects. Secondly, I mean, there are some reasons to be pessimistic about, the continuation of these sort of trends, but, there are physical limits we might begin to approach. But then again, parallelization is very much a thing that's, sort of tipped to sort of pick over where current gains are being lost. Maybe we'll see quantum computers. So I'm not really qualified to speculate to any great extent, but I think there's reason for a certain amount of confidence that we will see continued cheaper computing for some time yet, certainly long enough to have the kind of employment impacts that we're discussing.
Well, on the question of feedback loops, I wouldn't rule anything out, but I mean, this is nothing we try to predict in our work, and I don't have a qualified prediction to make. I think it's possible, but again, only wild guesses.
So I was really interested in your referencing of heuristics, essentially, with machine learning, the need to deepen the bank of experience, essentially. Do you think there's a need for more data sharing across platforms and between devices, some form of standardization, so there's cumulative sort of progress there in terms of machine intelligence?
How could I not agree with that? Of course, yes, absolutely. More data, please, as much as you can give us. Standardization across platforms, I completely agree with you. Yes.
What are the barriers, though, in terms of the specificity of those devices that you're developing? I mean, if they're completing different tasks, is that something you're addressing in your own work, or is it being addressed more widely?
Not directly. I mean, are you talking about lock-in effects where it might be difficult to standardize given what we've already seen? Or no, I don't know. Sorry.
Right, we have lots more questions. There's one right at the front, then two gentlemen in the third row, and then we'll do the next round, because I can see lots of hands going up, but we have plenty of time, so we will get round them all.
Hello, my name is Nicholas Tresilian from the International Institute for the Study of Time, and I apologize for my machine going off. There's two thoughts that listening to you makes me think. One is that we have a world with a lot of anomie in it already, and the algorithmic world is not going to get more cheerful in that way. And I wonder whether, in fact, we are beginning to create a market for a different kind of, a more relational kind of value, in which it would be, in which the carrying, if you like, capacities would be more valued than they are at present, in which expertise in those capacities, after a computer can't kiss you, despite the film that's going the rounds at the moment, there's a great deal that is not accounted for by rational efficiencies in human life that could be more highly valued than it is. And then, on the other hand, is that underlying sort of awkward feeling that we've pursued this race of growth as a species, and we're growing in population whether we still want it or not. And at the same time, people are becoming more expensive. They live longer, they cost more through the hospitals. We really need fewer of them and don't need to give them too much encouragement. So there's this sort of relational aspect of it, the relational good on the one hand, and on the other hand, a kind of cheerless background political situation in which, frankly, once people are over the age of 50, they're probably an embarrassment. And these things seem to sort of fight it. And so there is a big middle ground, it seems to me, not touched by computers as such, of human values flowing not all in one direction.
Well, I think, broadly speaking, if I understand your question right, I agree. I mean, there are certain things, there are certain human relationships that can't be replaced by computers. And that's also one thing which we are actually predicting, that jobs involving those type of skills will actually not. But I do also think that the way people communicate these days is actually much through computers. I mean, we're more okay with not having the sort of what one would perhaps have thought of as more of a human component 20 years ago, but actually on Facebook and the ways we interact, there is a human component to it, but it's a different way of interacting.
I was thinking of people being paid for doing things, really.
Sorry?
I was thinking of jobs, people being paid for doing things,
right.
Not just me talking to my relatives.
Right.
That was my question, to the extent. Can jobs be conjured out of this situation?
I would say yes. I think, these human skills are going to become more valued. Perhaps there will be new jobs created as a result. Perhaps personal chefs, to give one random example, will become more popular just, due to the increasing demand for human interaction in life. I don't know. Yeah, I agree with you.
You're giving us something to think about, let's put it that way.
Thank you for the talk. So you mentioned that probably some of the safer jobs would be the ones that require more social skills like persuasion. And what I thought right away was the insurance seller that would knock on your door and try to sell you an insurance, which today you basically go on a website to compare information. So clearly there are also those kind of jobs that have been at risk, if not necessarily by automation, but by the technologies that present information in more useful ways for us to make informed decisions. So my question is if you have looked into also the risks that comes with these kind of technologies, and what sort of jobs would also be at risk that would not be so clear just with automation of factories and processes.
So if I can tackle that. So this is a hugely important effect. So for example, let's think back to the typing pool in the 1950s, right? So a group of predominantly women who were employed to type. So a lot of what was seen as their job involved things that weren't just typing. So the ability to chat to other people, to make coffees maybe. A whole host of things that machines couldn't and still can't do. But nonetheless, when word processors came around, well, all those other things were sort of deemed not important enough to save the jobs. So you mentioned insurance sales. I think that's another example where basically it turned out that we could simplify what that job required to the point that it could actually be achieved by an algorithm or a machine. So another example of that I demonstrated was this robotic gripper that was just a hacky sack, basically. So can that do everything that a human hand can do? Of course not, but maybe it can do enough that it will substitute for humans in some manipulation type tasks. So I think this is a hugely important effect. To the extent that we could, we did take it into account in our analysis. We tried to think about ways in which jobs could be simplified. We tried to think about where the core skills of a job weren't actually the ones that were identified by the surveys. So we did try to take that into account, but even so, I think it's very difficult to forecast, and we probably will see more automation due to these kind of effects than even we've anticipated.
So a brief comment related to Moore's law, since I spent much of last night actually doing simulations trying to see where it would end. So if you try to do jackknifing and fit a sigmoid to it, my conclusion is it's kind of 99% certain that we're going to get at least 100,000 times as much computing power per dollar per second than we currently get. And that's the lowest case, and the higher ones are probably even unphysical in this case. But the real problem might be, of course, that hardware is irrelevant by now, because the cost of any microprocessor or even a pretty nifty computer is so much lower than the cost of an employee anyway. So it's actually the software that sets the price. And as I was arguing in my own talk a few weeks back, the nasty thing about software is that it's fundamentally unpredictable. Moore's law, at least you can try to fit a curve through, and it's probably not going to be totally crazy. In the case of software, you do get jumps. So it seems like in order to predict what jobs are really in trouble right now, one should probably run over to the various computer labs and check what software exists right now that people are experimenting on, because that in 10 or 20 years is probably going to be out there, and they are going to be affecting the jobs.
I really don't have much to say except to agree with you, and to thank you for backing up some of these optimistic forecasts about Moore's law. Oh wait, I will say one thing, which is that I think there is scope for the automation of software engineering. That's not something I think is beyond the realm of possibility. So, these trends may continue.
Yeah, your study have looked at how automation had perhaps take away some existing jobs. But I'm just curious, have you also looked at how the proliferation of the computer technology are also creating many new jobs? I mean, the fact that you have iPhone now, there are thousands of people writing mobile apps. 3D printing may remove routine factory job, but you created thousands of new 3D object designers. So maybe the job creation effect itself will result in many new jobs that doesn't exist in your current 700 job categories now,
Well, that is obviously very true, and in the study explicitly position ourselves to actually just examine the potential extent, scope of automation of existing jobs. And obviously there are going to be new types of jobs. We don't look at job growth in our study. We look at certain bottlenecks of automation. We think in the domains where those bottlenecks exist, there will be job growth. If it will be sufficient to make up for the job loss, that's a question that is left unanswered, and intentionally so, because we don't know. But I think the ability to create as many new jobs will vastly depend on upskilling the labor force in terms of reforming our educational system and making people acquire creative and social skills. Without that, I don't think you will have anything even near in terms of job creation to make up for the job loss.
If I could provide one additional comment, even if new jobs are created, there's going to be churn, right? So, workers will have to shift from one job that's been destroyed by technology to another that's been created, and that's not that desirable for a lot of people, right? This job market churn is something we've got to watch out for, and the fact that we're predicting so much of this job destruction to occur in low-skilled occupations is a bit alarming, right? That there might be so much turnover at that end of the spectrum. So.
Right, let's take another show of hands. The gentleman in the blue shirt here, and then over to the left-hand side. Clara, just there and behind.
Hello. I was just wondering, you seem to suggest that there wasn't much prospect of this sort of thing encroaching upon social intelligence and the applications that humans currently predominate. But then in the news recently, there's a piece about how they're starting to roll out robots to interact with children who are socially debilitated by autism, and I just wondered, obviously that's a platform, but I wondered to what extent you think sociability of robots and computers can be improved, and what are the bottlenecks, whether they're algorithmic, computational, or whether it's just a lack of data about how to respond to different situations, or whether indeed you could ever have enough data to be able to respond to nuances of all the different social situations that you encounter in your environment?
So I think the crucial thing in thinking about whether or not automation is going to be possible in these kind of tasks that involve social intelligence is the question is not about the technology, it's about the extent to which we can simplify the jobs, right? So someone who works at a cashier, for example, might assess that their job involves a lot of social interaction, but actually we're increasingly deciding that actually all that stuff is not that important. We're perfectly happy with the self-checkout. So, we may see automation even if the technology doesn't improve much because of those sort of effects. I think work will continue in effective robotics, this ability of robots to interact with people, but I think it's probably fair to say it's a long way away from achieving human aptitude. I've got every confidence that in maybe 100 years we'll have systems that are able to approach sort of human levels of human faculties for social interaction, but it's still a long way away. I think the sort of robots we're seeing now that interact with people are very much more towards the gimmick end than the kind of full substitution for a human worker. Again, quite happy to be wrong.
Thank you. There's already sort of mentioned a little bit about skill shortages and the role education might play in the future. And it seems to me that a problem we have at the moment isn't so much that people aren't spending a lot of time and resource in the education system, it's just maybe broad education system, people study lots of different things, it's not always producing the skills that employers might want at some point down the line. So, I guess given what you're saying, this suggests there's even narrower set of skills that might be the ones that are valuable in the labour market in the future. Do you think systems need to start being more prescriptive about what things are studied in education, that some degree courses we should just be saying, well, this is not going to be useful for you in the labour market? I guess one of your descriptions that law courses might fit into that category in the future, that things that encourage creativity or social development should be more pushed. To the extent that I guess that you think that creativity and social skills are actually well taught in the classroom or the lecture theatre, or maybe they're developed better elsewhere.
Well, there are obviously things that should be taught in the classroom which does not relate directly to the type of skills we would want workers to have in the labour market. Our educational system needs to be broader than that. But I think we need to do more in terms of investing in those type of skills which computer capital complements for us to be able to leverage that going forward. And what I think is also important is that we don't invest too much in too specific skills. Because if we start investing in skills that are only relevant to certain types of businesses and certain types of industries, and all of a sudden those don't exist any longer, I mean, businesses and industries come and go, but we still want our skills to be relevant. So my suggestion would be that we invest in transferable skills that can be applied in many types of occupations, many types of industries. Statistical modeling is such an example. It's being applied in the financial sector, business services, ICT, all sorts of things. So I think that's the main thing to keep in mind.
Okay. Your presentation found many jobs that are at risk of automation. Assuming those people are made redundant by the automation, who's going to pay for their pensions?
Good question. Don't know. Well, if there's nobody paying in pensions, there's not too much money coming in, right? So obviously this is a huge problem. And I think, looking forward, it may be that we need to reconsider how a lot of things are being structured and run, and the pension system is definitely one of them. But I'm not going to attempt to come up with a solution to exactly what that pension system should look like. But I do very much agree with you, it's a huge problem.
Do we have any more questions? And then right at the back.
I was just thinking earlier when you said it could take 100 years to fully replace social interactions. I was just thinking of personal experience. I don't know if this supports it or not. It was 45 years ago, I've just worked out. I was a graduate student in Oxford, sitting in the nuclear physics lab, waiting for my computer programs to finish, and running this program run by MIT called the Doctor program, that basically just kept asking questions and throwing things back and completely psychoanalyzed me. And this was the computing technology of 45 years ago. And yet it was extremely effective, if not sophisticated. Doesn't that show that there is an awful lot of potential there for computers to be able to act as social workers in some way? Not necessarily in a robotic sense, but in an interactive sense remotely.
Okay, so I think this comes back again to, machines that don't try and reproduce the full human faculty for social interaction, but they're able to, create just enough of it to substitute for a particular role. I think there is enormous scope for that, as I said, where we could, within the confines of our study, trying to predict which jobs may or may not fall into that category. I think we will see an increasing amount of it. But machines that are able to do everything that a human can to understand, the full richness of human social interaction, that's still a very long way away. Basically, we're just born with so much information about how to interact with people and gather so much over, childhood development. It's going to be a long time, basically, before we can program all that information into a machine. It's not on the immediate radar.
You're describing social intelligence as kind of an absolute quantity, but to make the obvious point, social intelligence is constructed, and obviously social intelligence for a teenager today is profoundly different than social intelligence for a teenager 10 years ago even. And so while we can talk about machines kind of aspiring to this notion of being human in their social, there's also, those machines want us to kind of go down to their level too. There's a way in which Siri wants, as the movie shows, Siri wants to be your friend and wants you to lower what is viable social intelligence or satisfactory. And so do you have a way that you're talking about that? Are there terms that you talk about this dynamic, the fact that what we understand as culture, and some gentlemen mentioned anomie in the front, but how that dynamic is going to be negotiated?
So, I think this comes back to the same phenomenon again of the extent to which humans are able to adapt to machines rather than the other way around, right? Like, to what extent are we able to come down to the level of Siri to kind of reconfigure our expectations for a task? I think to a great extent we will do that. I think there are a lot of occupations for which a completely human degree of social intelligence is not required. You're saying it's changing over time? I guess that's true. What is human is obviously a dynamic, constructed quantity, making things even more difficult for the machine to fully recreate that, I guess.
So, looking forward in the direction that these lines of progress point, I think it's interesting to ask, where does it seem that we're ending up as these trends mature? And we've spoken of the importance of social intelligence, and we've talked a lot about jobs. I would note that, first of all, a very large fraction of people, for reasons of age or simply their role in the world, do not have jobs. And they provide, by and large, social intelligence, social interaction for free. It's not a market good, it's something they do as human beings. So this leads me to ask, if much of the world presently does not, many of the people do not have jobs and yet seem to be valuing their lives and are valued by others, what are jobs for? If you're in a world in which your physical and information and service goods can be provided by machines, what are jobs for?
Well, I wouldn't say that I personally aspire to go to work and do things I don't want to do every day unless I didn't have to. So obviously, if we at some point in the future arrive at a place where work is not necessary, machines can do everything for us, and the only thing we need to do is redistribute, I would be all for that. But at the moment, as was said earlier here, we do have some issues with the pension system, and we do have some issues with a whole lot of things that would need to be redesigned in order for us to, at some point, achieve that. But I don't think work is something that needs to be there in order to keep people busy. I would at least manage to keep myself busy without a job as well.
So just a follow-on comment. What you've done is a very sophisticated analysis of the transitional period, of the trajectory that we're on from a world in which jobs are the basis of the structure of the economy, how goods and services are distributed.
Yep.
And in looking at where that transition should go, what are appropriate policies, I think it is important to ask, what does the end game look like? The end game that's really the opening of the door to a very different kind of world.
I agree with that, but I also think it's important to ask the intermediate question, which is what does the transition look like? And I personally fear that if we start asking the question now, what does the end game look like, we will end up at somewhere that we will find reasons for us not to work, although there is plenty of work that needs to be done. So while I agree that it's important to keep some kind of an end goal in mind, I personally think that managing the transition, which involves in getting people the skills to perform jobs also in the future, and those are the social and creative skills we've been discussing today, I think that should be at the top of the agenda.
I think at this point, I enjoyed the talk, but there is another aspect. You're talking technology. There is lots of it in medicine. And, the human being as we know it, due to technological advances, there is possible that they replace your arm, they replace your human parts, right? So the human being in the future may not be what we, it may look like us, but it may not be like us. So what about the attitude and, how do people function in this kind of modified sort of $1 million man, woman, whatever type of thing? So I think that is another aspect to consider as medicine, technology extends lives and the function of human bodies.
Hugely interesting question. I think,
I think that's a lot of scope for further research and additional papers. I don't disagree with that at all.
Yeah, I have a possible solution for the end game. I think it's called the Star Trek Society. So just a thought I threw
Following up on Eric's question about the end game and the transition, it seems to me that a very important question that I don't really have a good way to think about is this transition 10 years, 50 years, or 100 years? And it's hard to, I think it's very important if the time frame, because if it's 20 years away, then maybe, having these 5-year-olds learning about computer programming isn't the right answer either. It's maybe to learn more just life skills, or how to think more, or how to be more creative, or how to acquire hobbies. Something else might be the right thing. But if it's 100 years, then there's a different story. So do you have opinions or how to think about how far?
Yeah, I have strong opinions on this. So I quoted the example of Water and Levy, who in 2004 made this claim that, automated driving was never going to be possible. And then 8 years later, they were proved wrong. My point there was not that Water and Levy were dumb, because they're clearly not. I mean, forecasting is extraordinarily difficult. I mean, in my own field, machine learning, there have been these extraordinarily optimistic forecasts for going on 60 years about that as sort of a caveat to all our work. I mean, forecasting the future is extraordinarily difficult. So the focus of our study was as near term as we could make it while still being interesting. So we were considering sort of a 10 to 20 year horizon. And the kind of technologies we were considering were ones that were basically already with us, but perhaps hadn't reached the market yet. So we were trying to keep things as concrete and as grounded as we could in existing technologies, and to try and sidestep some of these extraordinarily difficult questions about forecasting future technologies.
I very much agree with that, but the only thing I would like to add is that we've been talking a lot about this Levy and Murnane book from 2004, The New Division of Labor, and I think obviously forecasting is one thing, but that is a very good book, by the way. So I think actually everybody should read that one, because that gave us sort of the starting point how to actually look at these things from, at least from the economist's point of view. Clearly there are difficulties making predictions, but that even if the predictions are wrong, it doesn't mean that it was necessarily a bad thing to start with.
Do we have any more before we wrap up? Oh, one down here. Oh yes, right, we're still going. We do have time, so we've got this lady here, the lady in the red shirt, and then there's two people in the middle on the left-hand side, Clara.
Hi, I just want to say I've been listening really carefully. I don't have a clear question that I could ask you and expect you to answer, but I do look and I see, on the one hand, we're talking about educating people to be better humans, actually, to be able to be more human and better able to deal with each other and with the world. And on the other hand, it seems the problem isn't really the automating. The problem is the income gap, the gap in between rich and poor. And because we put these two things together, we collate them as if they were the same problem. They're not the same problem. That in some way, it seems that automation in part happens maybe to save people from some disagreeable jobs, but also to make things cheaper so that fewer people can afford to buy them. So I'm just thinking, that's really all I have to say, is just this sense of collating these two problems makes one of the problems seem bigger than it really is. And I don't know what you can do about that. But
Well, I do think that the relationship between technology and this hollowing out we've been discussing is pretty clear. And I do think that it's difficult to separate the two, and obviously you can redistribute income and all of that. But I very much believe there is a connection between technology and inequality. And I think that needs to at least be the analytical starting point for thinking about how to perhaps go about making the world more equal. Start with.
Yes, hello. I was interested when you were saying about creative jobs being relatively safe. So I have a background in art history and psychology, and I don't want to knock the sense of aesthetics of the general public. But in terms of art, for instance, given that a lot of what people decorate their homes with was done in sweatshops in Asia anyway, but I could imagine that computer-generated artwork with clever marketing and computers that could copy persuasion techniques could do just as well or could replace what is the sort of average level of artistic human creativity. Same thing what you were saying about dress design, I think. I think that the design, an average computer-generated design could probably approximate a moderately, if not designer of genius. So isn't that field also at risk?
Could I speak? So computers are already contributing to creative tasks. Absolutely correct. So I have a collaborator who's working on automating statistics, actually, which is a bit alarming for me, because that's my job that's at risk, where the core creative task is sort of designing models, like building the right model for data. But so the contribution of machines to these kind of creative tasks is in proposing new candidates. What machines are still quite poor at is evaluating the quality of those candidates, if that makes sense. So it's very easy for a machine to chuck a painting out what's difficult for it is to get some sort of understanding of whether or not the painting is good or bad. What are the constituent elements that make it attractive to other humans? And of course, in the particular case of art and design, it's a moving target, right? I mean, trends come and go, which is very difficult for machines to keep up with. But there is a lot of work in this direction. But as I say, it's only going to be solved by enough big data to capture everything there is to know about a human's utility function or values, which is obviously going to be a lot of data that's going to be required.
And let me perhaps just add to that, that in the end of the day, we are deciding in the marketplace what is creative or not. And if a computer designs something that could possibly be creative, we are still the judges of whether that is creative. And to be more creative than we are, a computer will probably need to be more human than we are as well in that sense.
I was just going to comment, and it really follows on from that a bit actually, because I think one of the reasons you're so bullish about jobs requiring social intelligence is that you're assuming that everything else will change except social intelligence. And actually social intelligence is very much, what makes social intelligence, what actually affects social intelligence. And I think one of the things that affects it is trust. And I think that actually things like medicine and, that machines will actually be able to deliver better medicine and better diagnosis. And it actually might be that we begin to trust machines more than we trust people. And therefore, what constitutes social intelligence will also change. And it may be that jobs requiring social intelligence will actually start, as we know it, will start to disappear because it will be rather, sort of untargeted and it's just, not able to deliver what people expect.
So this comes back to Robert's question from before about, social intelligence being some sort of moving target. And I think to some extent, as I said, we will be able to simplify social tasks. We will be able to adapt to the machines rather than the other way around. I think that's a big part of it. But I would like to bring up Moravec's paradox, and I hope I've said his name correctly. So the paradox was kind of thought up in the 50s when the artificial intelligence experts at the time thought that something like football was sort of an easy task, for the common man, maybe even before the 50s, I should say, whereas something like chess was, high-level cognitive pursuit. So the things they thought were sort of the preserve of humans were things like chess, the things that were sort of bestial and, were going to be quickly replaced by machines with things like football. And they actually had that exactly the wrong way around, right? So football is very difficult to automate. Chess has proved to be very easy to automate. Now, the real distinction to make between those two types of occupations is how long have humans been doing those kind of tasks? So something like football, humans have been doing basically throughout our entire evolutionary history, right? Interacting with moving objects. Something like chess is kind of a very recent add-on. This is kind of built on the substructure that's been designed for something very different. So to come back to your original question, social interaction is, again, something we've been doing for a very long time. This is kind of a core part of what it means to be human. And as a consequence, simply due to Moravec's paradox, I think it's relatively immune to automation. I think the ability to interact with people is actually a lot more difficult than perhaps we sometimes give it credit for. It's quite difficult to design some of those things into a machine.
Great, that's all we've got time for. Thank you so much. Before we thank our speakers, I'd just like to flag up a new event that we've added to the roster that we're doing with the Future of Humanity Institute. It's on the 13th of May, and Dr. Joanna Bryson will be coming from Bath or Bristol, Bath, sorry everyone. And she's going to be looking at artificial intelligence. So if you've been interested in this seminar series, I highly recommend that you book in to come to that talk on the 13th of May. So please join me in thanking Carl and Michael. It's been a fascinating way to end our seminar series for this term. Thank you.